Whether you have a career in IT or it's just a hobby, having your own home lab is extremely useful. But what equipment do you need and how do you build one? Well, my own lab's actually up for a refresh, so that's exactly what I'll be covering in this video. Now, practically everything in IT is being virtualized these days. So for that reason, I want a server that's running at a hypervisor, and then I'll run virtual machines on top of it. I'll even go so far as actually doing nested virtualization, where I actually create hypervisors within that hypervisor, and then I can test out the functionality, for instance, of migrating a virtual machine from one hypervisor to another without having to actually have multiple physical servers. I mean, it does take a bit of a performance hit when you do it, but it's only a lab, so the performance isn't that big of a deal. It's just the basic functionality we're testing out, whether it's for our studies or whatever. So all I want to actually go with is one physical server that's running a bare metal hypervisor. Now, in the past, I used to just build my own computers, but nowadays you can buy refurbished actual enterprise grade servers relatively cheaply. So for that reason, I actually went with a Dell R620. So we'll jump on the web browser and I'll show you what I've been buying. So when you buy a used computer, chances are you're probably going to go to somewhere like eBay. So that's where we're at. Now, I am on the UK site, so you can see all these prices in pounds, but it doesn't really matter. I mean, it's just a case of I happen to live in that country, hence the reason I've picked that one. But in any case, I mean, if you do a search for, say, like a Dell R620, I mean, we get a lot of results here. And it's just a case of it's a very popular computer. It's been used a lot by companies and production environments, and they kind of like filter their way down into the to the likes of you and I who are buying them for individual reasons. I mean, there are some individuals selling these on that have probably used them at home computer labs themselves. But yeah, that's what it boils down to. Do you go for a refurbished one from a company, or do you buy it from a private reseller? Now, in the past, I did actually just buy from private resellers, but what's become more popular is companies like these ones, for example, who actually sell refurbished computers. So these computers they've been used in a production environment, no longer needed, and they end up in the hands of these resellers who then sell them on the likes of eBay or on their own website and so on. And you can see actually that's what they're actually targeting, because they've got a little question there, not the specification you're looking for. So you can see this is pretty much a bare bones one with one Xeon processor and 32 gig of RAM. You're not going to get much out of that. I mean, at least I'm not. I mean, if I was doing like networking, for example, I probably might. But I mean, I want to get into much more beefier sort of stuff, the sort of computing I need to do these days. So I need more memory, and I want dual Xeons because I want more processors. Well, I said dual Xeons, I want 2 Xeons. So it's a case of something like this is a lot more interesting in the sense that I can be very specific in how I spec out the computer. If you go further up to here, for example, this is an example, you get 2 8-core Xeons, but only 64 gig of memory, and you get 1.8 terabytes from a SAS drive, plus the RAID controller. Now, the problem with buying the RAID, I don't want to buy the sort of like hard drives that get used on these servers, because if they break, they're going to be expensive to replace. So I want to provide my own storage. So all I'm interested in is 2 Xeon processors and plenty of memory. Now, that server's set in its specification. If you buy this, but you want more memory, you're going to have to then either buy more memory to add in, or even possibly replace that memory. It just depends on how it's laid out. You can be a bit more selective in picking out how much memory that computer's got already in it, or you can come down to a company like this and basically just bypass eBay anyway, because that's effectively, to me, that's what the ad is. It's effectively a way of advertising on eBay. You're not going through a bidding process per se, because they're really targeting. You say, look, I mean, just come to our website and buy it, spec it to your needs, and you'll get a 1-year system warranty as well. Even doing that, you'll get the same warranty if you buy that specific one. But I want that flexibility to spec the server to what I want. And I really like that 1-year warranty that comes with it, because it means they'll build it to my spec, they'll test it out, and then they'll ship it to me. Then if something goes wrong within that year, I can send it back to them. Obviously, it's going to cost me the postage, but it's better than, say, buying something like that one, for example, because if that breaks, any part of it breaks, I'm going to have to replace it myself. Well, at least with this, yeah, it might be cheaper in, at least over that 1 year period, and it just gives me that peace of mind. So in any case, this is a computer reseller that happens to be in this country. I mean, I'm not affiliated with them. I've got no connections with them whatsoever. It just happens to be one that I've picked out. So if we go to their website, as you can see, they've got quite a few different servers that you can pick. And then it's a case of, we've got Dell R620s here. We've got R730s if you want to go that far. Pick out whichever sort of computer you want. Then you go to the Configure Now tab button there. Now, I've already gone and spec'd out one of these servers just to give you some idea what you're up against, because there's some things I wasn't aware of when I first started and things you've got to bear in mind. So straight up, you've got to actually select the chassis. You've obviously got to have a chassis, otherwise you haven't got a computer to begin with. So straight up, you're getting a certain price. The good thing I like about it, though, is you've got an iDRAC 7 enterprise license with it. Now, if you just have a bit of a click on the photo here, a top-down view of this server, you can see that we've got these fans along here, and these things they look small, but they are pretty noisy, I must admit, especially when the computer's booting up or when it's under load. So for that reason, I like to keep something like this in a different room. So that's where these iDRAC licenses come in very handy, because it means you can turn it on and you can turn it off at leisure. If something goes wrong, you can remote into the actual server through that iDRAC, effectively having console access to the server. So that's very, very useful to have, the fact that it actually comes with that license. There's no guarantee you go onto eBay, there's no guarantee you buy a server for private seller that you're going to get that license. So that was extremely useful. After that, it's a case of, well, you've then got to spec out what processor you want to use. So, for instance, I mean, two of these Xeon processors here that have got 8 cores, about £29 each. So select, I want 2 of those types. They get added into the total. The heat sinks, as it turns out, come with the actual processor anyway, so they're great. They were grayed out anyway, so it doesn't really matter. I mean, if I deselect these, put that back to 0, still grayed out no matter what I do. So they get added to your tool. And then you're into the memory, because you're not getting any memory at all. Now, if you go up back to that picture, you'll see there's a lot of slots, and it's a case of filling those slots with memory. So there's lots of flexibility in it. So for instance, you might say I want 12 of these 16 gig ones, so that gives you a total of 192 gig of RAM, and that gets added onto the list. Now, one thing I'll suggest is to add in these memory blanks. So the reason for that, it's to help the actual airflow within the actual computer. So once you've calculated how many of these memory sticks you're going to buy, basically work out how many blanks you're going to buy. So there's a total of 12 memory sticks I'm suggesting here. So we need another 12 actually as blanks just to help with the airflow. Now, when it comes to the actual storage, you've got choices. You can buy a RAID controller with it. Now, I don't want to get into this expensive stuff for me. The hard drives are quite expensive as far as I'm concerned. You've got to get, if they need replaced. I mean, 146 gig seems quite low. You're into, I'm not overly enthusiastic about them. So I just opted to stay clear of all this sort of stuff. And I'll opt for like no RAID controller because I don't want one. I'm not going to use any of their SAS controllers or SATA controllers. I'm just going to supply my own storage solution. So then we're into these hard drive caddies and the blanks. Now, it's going to vary. If you go and have a look at the front of the actual computer, that's what these slots are. These are where the actual hard drives would go. So to help with the airflow, if you're not going to put a hard drive in, you want to blank these out. Now, in my case, this model here is slightly different to mine. For me, I don't have these 2 slots here are already blocked out, so I only had to fill up 4 of the slots. So hence why if we go down to here, for example, we've got 4 actual blanking plates in for the hard drives. Yeah, 4 of these hard drive blanks. So that just basically, as I say, it's just to help with the airflow going in and out of the computer. You then need to pick an actual network card, because if you have a look at the back of one of these, there is no network card, and that would actually go in that slot there. So that's the port, your management port. So that's where the iDRAC is, that's your iDRAC connection. So you've got to pick out a network card to use for the computer, and you've got quite a few choices. The one I actually opted for isn't here. Mine's actually a dual. It's dual 1 gig, dual 10 gig. Here they've got 1 gig with dual 10 gigs. So that's why I've got that one picked as an example. I mean, you've got like half height cards and so on you can pick as well, but either way, you've got to pick out at least, some sort of network card to give you the network connectivity. Then it's a case of picking out the power supplies, because yeah, if we go back to that diagram, that one there, that's where your power supplies go, and there's nothing there. So you've got to pick out, you want at least one power supply. You don't necessarily need like redundancy, but for mine, like my peace of mind, it's a case of I pick 2 of them. Just went with the lower level 750s, because it's not going to be a very, very powerful computer, this one, in comparison to what it could be capable of. So yeah, just running it with one 750, keeping the other one more or less as a spare in case that runs into problems. It just saves me a bit of hassle later down the line, because if that power supply breaks, I can just carry on, and then I can order a replacement as opposed to waiting for a replacement to get sent. The bezel, entirely optional. You don't necessarily need one, but you can put one on the front to cover up and make it look a bit more cosmetic. Rack rails, you'll need to purchase those if you're going to put that into a rack. And then it's a case of, do you need to buy the actual lead, the power supply cable to power up from. So just to give you a rough example, I mean, that one there, like for example, it's 2 Xeon processors, so a total of 16 cores you're going to get out of that with 192 gig of memory. There's no storage in it, but you're looking at almost £650 here in the UK. So as a giggle, if we go and select out how much it's going to cost for a 192 gig computer here, I mean, you look at the variance on this sort of stuff. Someone there is asking for, that's a lot of money, $660.99, so that's slightly higher. Now that one, it's from the same company, but it comes with the server rails. You got somebody's mentioning that one again, 1380, 570. So it's a case of, it's going to vary. I mean, actually that's not too bad. It's comes with a bit of extra storage if you want it, but in my case it just gives you a rough idea of how much it's going to cost you if you buy it direct from them versus buying something similar through the eBay option. So yeah, I mean, there's a lot of flexibility there, so that's why I went down that option, especially because I got that flexibility in terms of the configuration, but also because it gave me that 1 year peace of mind, for the warranty. Now then, storage. I didn't opt for any storage at all with this when I purchased it. So it's a case of, well, what can you do? Well, when it comes to hypervisor, it's going to vary. I mean, you're going to need something to actually store the hypervisor on. And ESXi it's actually quite flexible, to be honest, because you can actually run it off a flash drive. Somewhere in there's actually a USB. I think it's that down there. I can't quite tell. I'll have to zoom in, but there's a USB drive, an internal connector, so you can plug a USB drive into it, and you can actually boot the server up from that USB drive. So if you want to use ESXi, you could do it that way. Other hypervisors are a lot more fussy. They won't let you do that. Now, what you can do is you can actually install an NVMe into this computer. It's got this riser card, PCIe slots, which mean you can actually get an actual PCIe card that allows you to plug an NVMe hard drive into it effectively, and that gives you an NVMe storage card. The trouble is the Dell server will not boot from it, so you can use NVMe as a storage medium, but you can't boot from it. So you've got that flexibility there where you could keep, you know, for ESXi in particular, you could just boot the actual operating system off a flash drive, but then use an NVMe for your actual storage. So you've got really good fast storage. Once it's up and running, it doesn't really matter. But the hypervisors, they're going to be a bit more fussy in the sense that they're going to have to do a lot of writing of logs, for instance. And for that reason, you're going to be needing an SSD drive. But that isn't here. You see, I didn't buy a RAID controller. I haven't bought any SATA or any type of SSD or SAS drives or anything. So what I did is I actually, well, basically I took advantage of the CD drive option, because this particular computer, it actually supports an optical drive. There's a couple of ports down here that support an optical drive, but you can actually buy a caddy that looks like a CD drive, but it actually gives you a slot to plug an SSD drive in. So I'll show you those in terms of what I've done, just to make it a bit more clear. So if we start with the NVMe storage, what you can do, in my case, I bought this Startech PCI Express card. So you can see there's the card there, and there's the slot for an NVMe. So basically what you do is you plug that into the riser card there, and then that gives you your, you know, NVMe for storage. And yeah, that to me was a no-brainer, really. It's not particularly expensive. This just happens to be, you know, we're on the UK card. If we jump to the on the UK site, if we jump to the US, it's about $35 if you buy it direct from them. Now, when it comes to SSD, you can actually boot off this SSD drive. So if you go into Amazon, for example, you've got this little caddy here. It looks like an actual optical drive from the front. They're more intended for laptops. The idea is it gives you an extra SSD drive instead of an optical drive, because not anybody uses CD drives these days. So what you've got is the slot there that you attach your SSD drive into, but you need to actually run a cable then from this back to the motherboard. So that particular reseller who sold me the server, I was able to get a cable. So that's what you need, is this Dell PowerEdge R620 optical cable, and that literally plugs into the motherboard. So if we go back to the photograph here, there's a couple of slots where you plug it into. So there's two cables, you plug it into here, and then the other end of the cable plugs into the actual caddy there. I don't know if it'll show you at the back. Yeah, there's you can see there's a slot at the back where you plug that cable into. So that's that bit there, and then those two ports there plug actually into the motherboard. So they plug into there. So the actual caddy just literally slots into the actual server at the top. What I found what was easiest to do was to attach the cable to the caddy, fish the cable itself through there. So that was the two plugs that I need to plug into here, and then I feed them through there into there. And then that's been an absolute godsend, because it now means I can run pretty much anything booted off the actual SSD drive and use the NVMe for my storage. Now if I want more storage, I'll just push it back to the NAS server that I've got, and then that can provide even more storage over the network. So yeah, I mean, to me it's a very, very flexible computer. I mean, you've got tons and tons of slots, so I've got quite a lot of leeway in terms of like upgrading it further down the line if I need to. But at this stage, 192 gig of memory, yeah, I think that's like way more than I need at this stage. I don't think I'm going to be going probably beyond like even 128 gig at a push. But that's what as I say, that's what I like about the flexibility of this, is just the fact that you can you can chop and change as to what you want in your initial purchase, and if you want something else further down the line, yeah, I could add more memory later if I wanted to. I can swap out the network card if I wanted to. I could, if I wanted to go down that option of SAS drives, yeah, I could do it. But yeah, it's pretty expensive, so I'm probably going to just stay clear of it. So once you've actually decided on how much you're willing to put aside for a server, bear in mind, this sort of thing's going to last me for quite a while, so it's an investment for me over the long term. Once I've finished with it, I'll probably just put it up on eBay and I'll get some of that money back anyway. But the question then is, well, what do I actually do with it? How do I make use of it? Now, once you've actually got a computer, the question is, well, how on earth do you configure it? And that's where documentation comes into play, because if you've been in the IT industry, you'll know that documentation is crucial. I mean, yeah, you can go some places and you can find the documentation's not up to date, there might be bits missing. In worst case scenarios, you can actually find this documentation's just non-existent, and then that makes life a lot more difficult. Now, when you're just getting started, you've got that opportunity to document everything, and it really pays you to do it, because you're going to have to implement this design, whatever it is you're going to do. And if you properly plan it, if you detail everything, it'll go a lot more easily. Whereas if you don't and you're just doing everything off the top of your head, you're going to run into problems probably. So document it, document it, document it, document it. Now, in my case, I've got two slightly different types. I've got a physical one and I've got a logical one. Now, the physical one, normally you would be very detailed. Like within this, you would have like ports, this network card plugs into this switch port and so on. But this is for more of it's a virtual environment. So it's a case of, I just really need to know how it's going to work upstream, because we've just got one physical server, which is the hypervisor. So fundamentally, all I need to know is, once I've plugged it into effectively an unmanaged switch, what do I need to configure it with? What IP address do I need? What do I need to point it to, and so on. So here I've got a very basic sort of physical overview where we've got a hypervisor, which is going to talk to a firewall. That firewall talks to another firewall, which in turn gets us access to the internet. Now, all that IP addressing is just made up on the fly. It's not real. If you've been in IT for a while, you'll know you do not detail this sort of information. It should never be made public. The diagrams, the IP addressing especially. I mean, even though the IP addressing here is private. I mean, okay, I've got some random public IP addressing down here, because that's what you would have when you're connecting to your service provider. Even though, a hacker can't get access to that IP address range, for instance, from the internet, the point is, you don't want somebody knowing that information once they're on your network. Otherwise, you're making it more easier. So it's a case of, say we've got a computer on this network, or somebody somehow manages to get a device onto the network. If they've got a hold of documentation like this, we're making their life a heck of a lot easier by telling them exactly what the network's environment looks like. So you'd never give this sort of information out. So for that reason, I've just come up with a bunch of IP addresses on the fly, just to give you an idea of, what you would put together when you actually are documenting it. So in all cases, I say, our home lab is just a physical server. It's going to be a hypervisor. So the sort of details I need to know about are, well, this is going to be my IP range. This is the subnet that this computer is plugging into, 172.16.16.0. The prefix length is 24. So I know the subnet masks 255, 255, 255.0. The default gateway is labeled here as .254, so it's going to be 172.16.16.254. And the server itself is going to need to be configured with an IP address, 172.16.16.50. Now, if anything ever accesses the internet, I've got details of my public IP address over here. I mean, I've just made this up on the fly again, but I'd know that if I ever access the internet, this device, this firewall out here, would do some network address translation. So anything on the internet would see this particular, any device on our network as 193.21.8.17, for instance. These are all information that I need to know for looking after this network, let alone, actually implementing it. So all this stuff will be, in place already. All we need to do effectively is just get this server configured, plugged into the network, pointed to the firewall, and that's it. Except we will need to know, what sort of rules to put on these firewalls, because for a long, long time, the security mantra has been, assume your network has been hacked. Assume there's somebody sitting on your network. It was quite a while back. There was a well-known vendor. It was purchased by another vendor, and it was found out somebody had been sitting on their network for like 4 years, completely unnoticed. So it pretty soon became common. It's not a case of just trying to keep, you know, hackers out on the internet from getting access from the internet. In other words, you're not just restricting access inbound, you're also restricting access outbound. You've got to set firewall rules up outbound to only what's necessary. If you need HTTP or HTTPS access outbound, allow it. If you don't need internet relay chat, don't allow it. Only allow what's necessary, because otherwise you're making life easier for a hacker. Now, common sense is saying, well, if you're giving hackers access to HTTP and HTTPS, what's the point? Well, the point is there are actually some devices out there, some hacking tools that actually don't use those protocols. So if you block those sort of things out, straight away you're ruling out a lot of tools that are available on the public internet from being able to get access out to the internet to, exfiltrate information once they've actually, been put onto your network. If you're in a business environment, you'd go that one step further, where you'd have content inspection of your web traffic. You'd decrypt it all, inspect it, check it, make sure that it's not, malicious, and then you would allow it, or you'd block it. You're going to have antivirus software on your computers to try to stop that in the first place, to detect it, when computers get affected. There's a lot of things go into security. It's all about, layers, trying to make it as difficult as possible. So even though this is a lab, we still want to make it as difficult as we possibly can, because last thing we want is, something on this network's getting hacked and actually getting access to our real network, for instance, where we're getting access to banking information through the internet, or where maybe you're storing private information on a NAS or something. You don't want anybody being able to hack your lab and then getting into that, because there's all sorts of things you'll be doing on your lab. You'll be building and constructing things. Yeah, I mean, you've probably heard about SolarWinds and all that sort of stuff. So it's a case of the sort of things you're going to be doing on here. You want to make sure that that never gets access to your own internal network either. Anywho, once you've got all that information down, we know what to configure a hypervisor with. We're then over into the actual logical design of the actual lab network itself. So that looks a bit more simplified. I mean, I've just got an internet connection, because as far as the firewall goes, then this is going to be a virtual firewall running on our actual hypervisor. All it needs to know is, well, what do I configure the IP address as? What do I point it to? After that, it's just an internet connection. So all of this is virtualized. That's the real network as far as the hypervisor is concerned, as far as this virtual firewall is concerned, because it's going to be sitting on the same physical network effectively to get access physically to the real internet. So it does need its own individual IP address. So we need to know what to configure that with. Now, I've gone the extra mile by splitting everything out into their own individual networks, again for security reasons, but also for some simplicity later down the line. I'm trying to emulate a real network as much as possible, because it's good practice to get into, and especially if you're going to be working for an employer who doesn't provide you with like a test environment. You can literally model that network on your home network effectively and run your own configuration tests, test patches, test routing changes, network changes yourself with your own kit before you actually submit them to CAB, for instance. There's all sorts of things you can do with an actual lab network, but it's a case of splitting things out, getting into that good practice for security reasons, and making sure you protect everything as best as you possibly can. So for this reason, we're going to have a virtual firewall, and we're going to split out our infrastructure servers, because that's what you would do in a real network. You don't want these existing in an open network where users, for instance, can get access to them. Users, computers, even servers, production servers, all they need is DNS access to this server, which is I've called NS1, for example. Again, all the IP addresses, they're private IPs, but I've just made them up on the fly. But this DNS server, if only people need is DNS access, that's all we're going to give to it. So we stick it behind a firewall. So if there's ever a software bug on this, somebody can't exploit it. If there's some bug in the kernel, for instance, nobody can exploit it by coming through the firewall because we're only allowing access to DNS. If we accidentally make a mistake in the software firewall, we're still protected by the virtual firewall here from anybody getting past the software firewall on there. It's the same with the DHCP server. You only need DHCP access to it. That's it. I wouldn't want users or computers being able to get exploited and being able to get SSH access into my DHCP server, for instance. So we stop it at the firewall. I mean, yes, people make mistakes within the firewall itself. We could accidentally allow a rule, hence why we'll then be putting a software firewall on these to only allow the necessary access to the actual DHCP server as well. It's all about layers. Now, the reason I actually want a DNS server is, well, like a real network, you need to get access to DNS. But it's a case of, I want, computers over here to only talk to that server through DNS. Same as I would in a real network. I wouldn't want to give them access to the root servers or specific servers like, providers like Google, for instance. I want to control what they can get access to because it makes it difficult. It makes it harder for a hacker. If somebody puts a piece of software on your computer and they've got, some servers sitting out on a cloud provider, if they've got to do DNS resolution, for example, but they can't do it through there, they can't go to their own choice of DNS servers. I'm making it difficult. I'm forcing them through a certain DNS solution. So they can't just spin up some computers in a cloud that are going to constantly be moving backwards and forwards through different clouds, where their IP address is going to change, but their DNS name stays the same. I'm going to block that straight away by forcing them through a DNS server here. And then that DNS server itself is going to go through a set of DNS servers out on the internet to go somewhere to providing DNS security. The benefit of that is that it makes my life easier. The firewall rules on here say you can have DNS access to that server, and then that server has DNS access to specific servers on the internet. If I want to change those servers to, say, like I want to shift from Google to Cloudflare to off to Cisco, for example, I only have to make a couple of changes on the DNS server rules over here on this firewall and never have to make the changes on here. So it's very easy to do that migration. You just got to then wait for the, for the DNS cache to flush for that switch over to take place. So it makes life a lot easier to do it, for making the changes. But as I say, it gives me that element of security that somebody can't bypass the DNS security that you put in place either. So yeah, we've got our NS server over here protected. We've got our DHCP server over here protected. And we do want access to DHCP because I want to be able to spin up computers on the fly. I don't have to go through a manual process every time because some of these servers are just going to be, they're just going to be created, they're going to be tested, and then they're going to be thrown away. So there's no point, giving them a static IP address. I'll just spin it up. It'll get its IP address, which means this firewall here will have to be configured as a DHCP relay because these computers will just broadcast a request for DHCP. The firewall will pass it to the DHCP server. Once that's all sorted out, it's just going to be the PCs or server, whatever it is, it'll just keep talking directly to the DHCP server. When it comes to the management of your computers, including ones like that, you want to have a dedicated management solution. So, in an ideal world, you'd have an out-of-band management solution. In our case, this is all virtualized. So we're doing this for security reasons where we don't have these exposed on a flat network. We don't want people getting direct access to these. If anybody wants to manage these, I want them to manage it through a specific machine. And it makes it much easier to keep an eye on security because if this machine is the only machine that can get access to these, it's the only machine we need to lock down. It's the only machine we need to keep an eye on and making sure it's always constantly patched with the latest updates, to check its logs to see what it's getting up to. I don't have to worry too much about what's going on up here. I can focus my attention on here for any nefarious actions, if you will. So it's a case of, we might set it up so that this management server's got SSH access to these two Linux servers, because I will be using Linux. There might be other protocols I want to set up, but at the very least, it will probably be something like SSH. I also want to use this to control the firewall, because even though technically that's an internal network as such, from the perspective of this network here, this is the internet. It's the outside. It's the most untrusted network there can be. So we don't want anything coming into the firewall. We want to tightly control what can get out through the firewall, but I've still got to be able to manage it. And a lot of firewalls these days, you manage them through a GUI, hence the reason I need this management server over here. Now, because it's running on a hypervisor, it's a virtual machine on a hypervisor, I can make my life easier. I can just control that through a console, through the hypervisor itself. I can even do it through these servers, to be honest. But the idea is I still need at least that server to configure this firewall. So effectively, this is the management interface of the actual firewall. This is our outside interface, our worst case scenario, our most untrusted network, whereas this is our most trusted network. So it's a case of, yeah, we've got to get that one built regardless. We've got to then get our firewall up and running, and then we'll start getting these built before we get all this lot built. So all of this information is detailed, it's documented, it tells me, how to implement all of these, what IP addresses to assign, what subnets, what default gateways, and so on. And then once we know that, we can then go through the actual implementation process, and all of this will just stay in place for the entirety of the lab. I'll then be able to spin up virtual machines, either within the hypervisor itself or within hypervisors running in that hypervisor we're running on as the bare metal hypervisor on the physical server. That'll just stay, that'll be where things change. Over here we might spin up new networks for different things, in which case we might need to do updates for DNS, updates for DHCP, but these virtual machines will just remain for the entirety of the lab. So it's pretty simple to do. You just need one physical server, get this configuration and implementation done, and then you can start actually doing your lab work. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, because that encourages YouTube's algorithm to suggest it to other people who might find it useful as well. If you're new to the channel and you'd like to see more content like this, then yeah, do subscribe. Just remember to click the little bell icon though, that way you'll get notifications when I send new content out. If you've got any comments, any suggestions, if you want to leave any feedback at all, please post that in the comments section below. And if you'd like to support the channel, I've left links to both Patreon and PayPal in the description below. But above all, thanks very much for watching. I'll see you in the next video.